Okay, here's sample problem 16.4. Determine the pH of a solution at 25 degrees C in which the hydronium concentration is A, 3.5 times 10 to the minus 4 molar, B, 1.7 times 10 to the minus 7 molar, and C, 8.8 times 10 to the minus 11 molar. pH calculations of this sort are really of some of the easiest calculations to do. You just plug it into the formula and then use your calculator to do it. You just have to be familiar with how to hit the right keys on your calculator. So let's start with A. Okay, so we know the concentration is 3.5 times 10 to the minus 4 molar. So the pH is just the negative log of that. pH is a unitless quantity, so don't worry about the molarity. So negative log of that is 3.46. Okay, so we would say this is pH 3.46. It's less than 7. So that means this solution is acidic. Okay, there's more hydronium in the solution than there is hydroxide. One note about significant figures. The sig figs are determined in the following way. There's 1, there's 2, so there's 2 sig figs. But when you take the log, the sig figs appear after the decimal point. So don't count the 3 as a sig fig, just the 4 and the 6. So there's 2 sig figs right there. Let's start with B. B says that the concentration of hydronium is 1.7 times 10 to the minus 7. So the negative log of that. And that comes out to 6.77, 2 sig figs. Okay, this one's still acidic, but very slightly. It's only a little bit under 7. That is close enough to 7 that we would say it's close to neutral. Not exactly, but close. Okay, the last one, pH, negative log of 8.8 times 10 to the minus 11. Okay, so for that one we get 10.06. Again, 2 sig figs, 1, 2, 1, 2. That's basic, right? Or alkaline if you want to use a fancier word. Okay. All right, there you go. So just make sure you're familiar with how to do this on your calculator. When you take the log of something, you'll get a negative number, but then you put the negative in front of it and it makes it positive.